China just told its robots to clock in. Not next year, not in 5 years, not when the technology is ready enough. November, this year. Real factories, real assembly lines, real work. And if you think that it sounds like a government press release nobody is going to take seriously, consider this. The last time Beijing set a hard industrial deadline with this kind of money and political weight behind it, they built the largest electric vehicle industry on the Eon. Ask permission. They did not wait for the market to organically develop. They picked a target, pointed the entire machinery of the Chinese state at it, and hit it. So when Beijing says humanoid robots will be working in factories by November, the rest of the world should probably stow-pea laughing and start paying attention. Because this is not a science fiction story anymore. This is an economic strategy. And it is already in motion. Let us go back to where this actually started, because the headline makes it sound sudden, like some official woke up one morning and decided robots needed employment. But the groundwork for this moment has been building for years, and understanding that groundwork is the only way to understand why November matters and why what is happening in China right now is genuinely one of the most consequential industrial shifts of our lifetime. In 2023, China's Ministry of Industry and Information Technology released a document that did not get nearly enough attention outside of policy circles and robotics research communities. The document outlined a national roadmap for humanoid robot development that was breathtaking in its ambition and almost uncomfortable in its specificity. It did not say, we would like to explore the potential of humanoid robotics. It said China intended to build a complete humanoid robot industry chain by 2025, with mass production capabilities in place and robots actively deployed in key sectors. The document set out a timeline, identified bottlenecks, designated funding streams, and named the exact industries where these robots would be placed first: manufacturing, logistics, healthcare, hazardous environments. The document read less like a research proposal and more like a military operation plan, with objectives, milestones, and accountability structures built into every paragraph. At the time, many analysts looked at that document and filed it away under ambitious, but probably overstated. China has produced ambitious industrial roadmaps before that took longer the ferret from the original vision. So the skepticism was not unreasonable. But then, something happened that changed the tone of the conversation entirely. Beijing put real money behind the WSLOA. Funding that gets spread thin across 100 different research projects and disappears into administrative overhead. They created a dedicated $1.4 billion state robotics fund specifically targeting humanoid development. They opened the Beijing Humanoid Robot Innovation Center, a government-backed institution whose sole purpose is to solve the two hardest problems in humanoid robotics: the artificial intelligence architecture that serves as the robot's brain and the mechanical engineering that serves as its body. And they head up a subsidy structure that directly rewards companies for getting robots onto factory floors before the end of 2024. Not for filing patents, not for publishing research papers, not for impressive trade show demonstrations, but for actual deployment in actual working environments. That is the critical difference between what China is doing and what most of the world is still doing with humanoid robotics. The rest of the world is still largely in the phase of being impressed. We see videos of robots walking, running, doing backflips, and we respond with a mixture of wonder and mild unease, and then we move on to the next content cycle. China has moved past being impressed. They are now asking the robot to justify its existence economically, to demonstrate that it can generate value in the real world, to prove that the billions of dollars being invested in this technology will produce returns that show up not just in innovation metrics, but in actual industrial output. That is a fundamentally different conversation. And it is one that the rest of the world is going to be forced into eventually, whether it is ready or not. Now, let us talk about Tiangong, because if you want to understand what China's robot looks like, what it is actually capable of, and why it matters that it exists, Tiangong is the place to start. Unveiled in mid-2024, Tiangong is a full-sized humanoid robot built entirely on electric drive system. No hydraulics, no pneumatics. Just electric motors and advanced control systems working together to produce movement that, when you watch it, genuinely stops you for a second because it is smoother and more natural than almost anything the public has seen from humanoid robotics before. It stands roughly the height of an average adult human. It can walk across uneven terrain without losing its balance. It can run, not shuffle awkwardly in a way that technically qualifies as running, but looks like a catastrophic fall happening in slow motion. Actually run with the kind of gait stability that suggests the underlying control systems are doing something genuinely sophisticated. What makes Tiangong particularly significant is not just what it can do, but what it represents in the political and strategic context of the November deadline. This robot is not a university research project. It is not a startup's proof of concept looking G for Series B funding. It is a government-backed flagship product designed to be the visible symbol of a national industrial push, and it has been specifically positioned to lead the charge into Beijing's factories before the year ends. The Beijing Humanoid Robot Innovation Center, which played a central role in Tiangong's development, has been tasked with using this robot to establish the technical standards that will govern the entire Chinese humanoid robot industry going forward. In other words, Tiangong is not just a robot. It is the template. Get the template right, get it into factories by November, prove it works, and then scale it across the entire Chinese manufacturing sector. That is the plan. And the manufacturing sector they are targeting is not small. China's industrial base is the largest in the world by virtually every measure. The country produces more steel than the next 10 countries combined. It manufactures approximately 28% of global goods output. Its automotive manufacturing industry, already transformed by the electric vehicle Revolution N, now employs millions of workers and operates at a scale that is genuinely difficult to comprehend from the outside. When Beijing says it wants humanoid robots working in these factories, it is not talking about a few pilot programs that will produce some interesting data and some good press releases. It is talking about eventually replacing or supplementing a workforce of tens of millions of people with machines that can work 24 hours 80 AA, do not need health insurance, do not take sick days, and do not go on strike. The economic logic of this, from the perspective of Chinese industrial planners, is almost brutally straightforward. Policy step. But there is another layer to this that goes beyond simple labor cost calculations, and it is the layer that explains why November is a hard deadline rather than a soft aspiration. China has a demographic problem. The one-child policy, implemented decades ago and only recently relaxed, has produced a population structure that is aging faster than almost any other major economy. The working-age population is already declining. The ratio of workers to retirees is shifting in ways that are going to create enormous economic pressure over the next 2 to 3 decades. Economists who study Chinese demographics have been warning about this for years, using phrases like getting old before getting rich to describe the risk that China's workforce will shrink before the country has fully transitioned to the kind of high-income, high-productivity economy that can sustain an aging population. Humanoid robots are, in significant part, a solution to this problem. If you can deploy robots at scale in manufacturing, logistics, and services, you can maintain or even increase economic output, even as the human workforce contracts. You can decouple productivity from headcount. And you can do it fast enough to stay ahead of the demographic curve rather than being crushed by it. This is why the Beijing directive has the weight it has. This is not a technology ministry getting excited about cool gadgets. This is economic planning at the highest level, driven by an understanding that the window for solving the demographic problem through tech, no logical means, is closing, and that every year of delay is a year of competitive disadvantage. The November deadline is not arbitrary. It is a forcing function designed to compress the timeline between research and deployment, to push companies past the comfortable phase of endless iteration in controlled environments and into the messy, high-stakes reality of actual industrial operation. Let us talk about the companies that are going to have to actually deliver on this directive, because Beijing can set all the deadlines it wants, but ultimately robots are built by engineers, not by government mandates. The Chinese robot ICS ecosystem has developed with remarkable speed over the last several years, partly driven by the same state investment that is now pushing toward Novi. Ember, and partly driven by a genuine explosion of engineering talent and entrepreneurial energy that is producing companies you have probably never heard of, but probably should have. Unitree Robotics is one of the names you need to know. Founded less than a decade ago, Unitree has developed a series of quadruped and bipedal robots that have drawn serious attention from engineers and robotics researchers globally. Their H1 humanoid robot has been shown performing tasks that would have seemed like science fiction just a few years ago, and they have been aggressive about publishing performance data and making their technology accessible to researchers and developers in a way that has accelerated the pace of improvement significantly. They are the kind of company that turns a government deadline from an abstract policy goal into an engineering challenge with a real solution path. Then there is Robotics, which has been in the humanoid space longer than most, and has relationships with major Chinese manufacturers that give it a direct pipeline into the factory environments. Here, these robots need to eventually operate. Ubtech has been quietly deploying robots in automotive manufacturing contexts for the last couple of years, building the operational experience that will be essential when the scale-up begins in earnest. To understand not just how to build robots, but how to integrate them into complex existing workflows without destroying the productivity of the human workers around them, which is actually one of the hardest parts of the whole enterprise, and one that tends to get underestimated in the coverage of humanoid robotics. Beyond the individual companies, what China has built is an ecosystem, a supply chain, a talent pipeline, and a policy environment that all point in the same direction at the same time. That kind of coordinated industrial development is something China has demonstrated an unusual capacity for, and it is why the skeptics who look at the November deadline and say, no way, the technology is not ready, may be missing something important about how Chinese industrial strategy actually works. The technology does not have to be perfect by November. It has to be good enough to be useful. And good enough to be useful is a very different and much lower bar than impressive enough to go viral on social media. Now, here is where we need to be honest about the challenges, because a script that just cheerleads for China's robot program without acknowledging the very real obstacles in front of it would be doing you a disservice. The obstacles are significant. They are not insurmountable, but they are real, and they explain why even with all the political will and financial e-sources in the world, deploying humanoid robots at scale in November 2024 is going to look more like a serious beginning than a completed transformation. Battery life is problem number one. Current humanoid robots, including the most advanced ones being developed in China and everywhere else in the world, can typically operate for somewhere between 2 and 4 hours before needing to recharge. GE. For a human worker on an 8 or 12-hour shift, that is a catastrophic limitation. You would need multiple robots to cover a single shift, plus the infrastructure to charge them, plus the logistics of managing the rotation, and suddenly the economics that made humanoid robots attractive start to look a lot more complicated. The battery problem is not unique to humanoid or robots. It is a physics problem, but it is particularly acute for humanoids because their bipedal locomotion systems are inherently energy intensive. Balancing a two-legged robot against gravity, while it performs complex tasks, requires constant micro-adjustments from dozens of motors. And those adjustments burn through battery capacity at a rate that current battery technology struggles to accommodate for extended operational periods. Dexterity is problem number 2. Walking is solved, or close enough to solve that it is no longer the limiting factor. Running is almost solved. Navigating G-complex environments, climbing stairs, recovering from unexpected physical disturbances, these things are getting there. But the fine motor control required for many manufacturing tasks, the ability to manipulate small components with precision, to handle materials of varying textures and weights, to perform assembly operations that require sensing force and adjusting grip in real time, that is still genuinely hard. The human hand is an engineering marvel that took evolution millions of years to develop, and replicating its capabilities in a mechanical system that can be manufactured at scale and maintained reliably is one of the deepest unsolved problems. In robotics, current humanoid hands are functional but limited. They can perform the tasks that have been specifically designed for them to perform, but they struggle with the unpredictable variability of real-world manufacturing environments. Cost is problem number 3. And arguably the one that will determine the pace of deployment more than any technical limitation. A state-of-the-art humanoid robot currently costs somewhere between $80,000 and $150,000 to produce. At that price point, the economic case for replacing human workers is narrow in most manufacturing contexts because human workers in China, while no longer as cheap as they once were, are still significantly less expensive over a 5-year period than a robot that costs $100,000 up front plus maintenance, plus the infrastructure to support it, plus the software development costs of adapting it to your specific production need. The Chinese government's target is to drive the cost of humanoid robots down to somewhere between $20,000 and $30,000 through the economies of scale that come with mass production. That is a plausible target, but it requires first achieving the mass production volumes that will generate those economies of scale, which means you need to deploy robots before they are cheap enough to easily justify the deployment, which is a classic industrial chicken and egg problem that only state subsidy structures can really solve in the timeframes being discussed. And then there's the AI problem, which is in some ways the deepest and most interesting challenge of all. A humanoid robot is only as useful as the intelligence that drives it. The mechanical hardware, as impressive as it has become, is ultimately just a vessel for the software that tells it what to do, how to respond to its environment, how to learn from mistakes, and how to generalize from specific training scenarios to the unpredictable variability of real-world operation. The current T-state of robotics AI is genuinely impressive in narrow, well-defined tasks. Robots trained to perform specific assembly operations in controlled environments can be remarkably capable and reliable. But the moment you introduce variability, the moment something unexpected happens, the moment the lighting changes or a component comes in at a slightly different angle or a human arc moves through the robot's operational space in an unanticipated way, current AI systems start to struggle. building AI that is robust enough to handle the full complexity of real industrial environments across thousands of different factories, across hundreds of different industries, across millions of different operational scenarios, is a problem that requires not just computational power, but fundamental advances in how we build and train machine intelligence. China is aware of all of these challenges. The Beijing Humanoid Robot Innovation Center was specifically created to address them, with working groups focused on EC of the major technical bottlenecks and a mandate to develop standardized solutions that can be shared across the industry, rather than having every company independently solve the same problems in incompatible ways. That kind of coordination is unusual in the technology sector, where companies typically guard their technical innovations as competitive advantages. But in the context of a national industrial strategy with a hard deadline, sharing solutions to common infrastructure problems while competing on the specific applications and products built on top of that infrastructure is a rational approach, and it is an approach that China's industrial planning apparatus is well structured to enable. Now let us zoom out for a moment and put all of this in the context of the global competition that is really the subtext of everything happening with Chinese humanoid robots. Because Beijing did not decide to order its robots to get a Joe B in a vacuum. This decision exists in a specific competitive context, and the name that comes up most often in that context is Elon Musk. Tesla's Optimus robot has been one of the most talked about projects in the humanoid robotics space since Musk first unveiled it in 2021 by having a person in a robot costume dance on stage, which was genuinely one of the stranger moments in recent technology history. In the years since that unconventional introduction, Optimus has evolved from a conceptual provocation into something that appears to be a serious engineering project. Tesla has published videos showing Optimus performing manufacturing tasks inside Tesla's own facilities, sorting components, moving parts between stations, performing simple assembly operations. Meizu SK has claimed that Tesla will produce enough Optimus robots for internal use in 2025 and will begin selling them to other companies in 2026. He has suggested, with the particular variety of confidence TH tends to make engineers nervous, that Optimus could eventually become Tesla's most valuable product. More valuable than the cars, more valuable than the energy business, more valuable than everything else combined. Whether you believe the most ambitious version of Musk's projections or not, the underlying reality is that Tesla is a serious competitor in this space. The company has genuine advantages in AI development through its work on autonomous driving, a manufacturing expertise that is hard to replicate, and access to capital markets that give it flexibility that most robotics startups can only dream of. China's decision to push for November deployment is, in significant part, a decision to not let Tesla set the terms of this competition. If Optimus is in Tesla's factories in 2025, and Chinese humanoid robots are still in research labs in 2025, that gap becomes a story about Chinese technological lag that Beijing is absolutely not willing to let become the dominant narrative. November is, among other things, a statement of intent. We will not be the country that watches someone else's robots change the world. We will be first, and it is not just Tesla. Boston Dynamics, the American robotics company now owned by Hyundai, has been producing humanoid and non-humanoid robots with CA abilities that still impress even expert observers. Figure AI, a startup backed by OpenAI, Microsoft, and NVIDIA, has developed a humanoid that has been shown in partnership with BMW performing automotive assembly tasks. Agility Robotics has deployed its Digit robot in Amazon warehouses. The competitive landscape for humanoid robotics is more crowded and more capable than it has ever been, and China's response to that landscape is not to try to beat every competitor on every technical metric simultaneously, but to leverage the one advantage that no American or European competitor can match: the scale and coordination capacity of the Chinese industrial state, combined with the scale of the Chinese manufacturing economy that these robots are designed to serve. Think about what it means to have direct government-orchestrated access to the largest manufacturing base in the world as your testing and deployment environment. American robotics companies have to convince individual companies, one at a time, to take the risk of integrating unproven technology into their production lines, to accept the productivity disruptions that see it with own with deployment, to invest in the infrastructure and training required to make robots operational. Chinese robotics companies, with government backing and government negotiated access, can deploy across entire industrial sectors simultaneously. The feedback loop between deployment and improvement is compressed dramatically. Problems that would take years to identify and solve in a fragmented market are identified and solved in months when you have hundreds of factories all running the same technology and sharing their operational data with a central development team. That acceleration effect is perhaps the single greatest advantage China has in this race, and it is not an advantage that can be easily replicated by market-driven economies without a fundamental restructuring of how technology deployment decisions are made. So where does this leave us as we approach the November deadline? What should we actually expect to see, and what should we expect to follow in the years after? What November is likely to look like is not a scene from a science fiction film. You're not going to see gleaming factories entirely populated by humanoid robots, while human workers watch from the sidelines. What you are more likely to see is a series of carefully chosen pilot deployments in specific factories, in specific parts of those factories, performing specific tasks that have been selected because they represent the best current match between what the robots can reliably do and what T-factories actually need done. Tasks that are physically demanding and repetitive, tasks that occur in environments that can be partially structured to make robot operation more reliable, tasks where human oversight is readily available to handle the exceptions and edge cases that the robots cannot yet manage independently. These deployments will be real. The robots will be doing real work. But they will also be the beginning of a learning process rather than the end of a development process. Every hour of operational data from those November factories will feed back into the systems that make the robot better. Every failure mode that appears in real operation will become an engineering problem with a dedicated team working on the solution. Every unexpected challenge that the real-world environment P resents will inform the next generation of hardware and software. The November deadline is not the finish line. It is the starting gun for the phase of development that actually matters. The phase where robots learn to work not in controlled conditions, but in the beautiful, chaotic, unpredictable reality of human industrial civilization. And here is the thing that makes this moment genuinely historic. The thing that elevates it beyond a story about trade competition or technology development or geopolitics. We are at the beginning of a shift in the relationship between human labor and machine capability that is going to be more profound than any previous wave of automation. Previous automation waves replaced specific human functions. The spinning jenny replaced hand spinning. The assembly line replaced decraft manufacturing. Industrial robots replaced the physical labor of specific repetitive tasks. But humanoid robots that can operate in environments designed for humans, using tools designed for humans, performing tasks designed for humans, represent something categorically different. They are not replacing a function. They are replacing the physical presence of a hum, and being in a production environment, and eventually in other environments too. The implications of that F, or employment, for economic distribution, for the social contract between labor and capital, for the definition of work itself, are going to be vast and are going to unfold over decades, not years. China is making a bet that it wants to be the country that leads that transition rather than adapts to it. Beijing is betting that the country which builds and deploys these robots at scale will have an industrial advantage in the second half of the 21st century that is comparable to the advantage that countries which industrialized first had in the 20th century. Whether that bet is correct depends on 1,000 factors that are impossible to predict with confidence. But the bet is being made. The resources are behind it. The deadline is set. The robots are going to work. The question now is not whether humanoid machines will transform industrial civilization. The question is which civilization's machine will do the transforming, and whether the rest of the world is paying close enough attention to understand what that question really means before the answer is already written. November is coming, and the robots are clocking in.